Hello everyone. I will be sharing with you today a presentation on BIM, which is Building Information Modeling, and its relevance to construction industry and construction companies, more so, especially with its importance in the world as we go forward and with reference to COVID and sustainability. The presentation has been prepared along with my colleague Ashit, and he is the technical expert here, and I hope he will be able to attend part of this conference as he had not been keeping well. And I will just begin to share the presentation. Give me a moment. So here we're going to look at building information modeling with special reference to construction industry and construction companies. So let us look at what are some of the core issues that are typically faced by construction companies and which may even be highlighted further in this post-COVID era. There will be fewer jobs in the market, increasing number of agencies bidding for the same projects. It would be important to quote at lower margins or more effective quotes rather than lose the project. There are typically in project delays which happen due to miscoordinated drawings, and that makes you lose time and money and perhaps the client's trust as well. There is bad cash flow and inventory management and loss of profitability. There is high volume of wastage. So if all of these can be more efficient, the entire industry would be more efficient and not just increase bottom lines, but also would work towards sustainable development because it would be utilizing fewer resources. So inaccurate estimates is another area which is one of the main causes and which causes wastage and time delays. There would be lower profit bid. Then construction delays typically are called inaccurate cash flow estimates, and then there are delays in procurement. There would be miscoordinated drawings. Very important aspect is clash between different building elements, and we all know how much everybody has to be so present at the site. It involves major site involvement, trying to resolve these clashes at site. So BIM is a solution that helps to achieve greater efficiency and also improves bottom line. It creates for very accurate and verifiable quantity takeoffs, if, of course, with the caveat that if the BIM model is well prepared and well coordinated. You get the most accurate estimates. It provides opportunity for lowest possible bids. It provides for accurately planned cash flows. There is early detection and resolution of clashes at the pre-construction stage itself. And all of this would go for a better project, a better client confidence, and improved bottom lines. So what is BIM? BIM, or Building Information Modeling, is a process for creating and managing information and on a construction project across the entire project life cycle. One of the key outputs of this process is the building information model. That is a digital description of every aspect of the built asset. So this model draws on information assembled collaboratively between the designers, architects, engineers, MEP consultants, all of the role players. And this is updated at key stages of a project. So typically we can say that BIM is an intelligent 3D model process that integrates people, data, and technology to optimize building design, construction, and operations. So what is the kind of information that goes on to the model? So a BIM object is a combination of many things. Product properties such as the thermal performance, could be the structural capacity, the geometry representation of the product's physical characteristics, visualizing data, giving the object a very recognizable shape. Then there's functional data such as dissection zones that enable the object to be positioned and it will behave in the same manner as the building itself. So it's an entire simulation of the building. And also for the various plugins, integrate several other outputs which you can generate from BIM models. There can be specifications, operating schedules, all of those input outputs can be obtained from BIM modeling. So these are intelligent 3D models, unlike the presentation 3D models. So this is real life building elements such as walls, floors, doors, ducts, pipes, etc. used to build the model on a computer. A multidisciplinary model is used to detect clashes between the elements. That means all the MEP, structure, architectural elements are already pre-designed and seen, visualized in a three-dimensional model and resolved even before the start of construction on site. The building elements in the 3D model have dimensional and physical properties that can be quantified and extracted. That means each element can have, let us say, if it has the thermal properties, then we can see the behavior of the entire building in response to the different climate. We can see its total energy consumptions. All these may, of course, require certain plugins. Here's an example how it works in terms of coordination and clash detection between architecture, structure, and MEP. So in BIM, typically there are LODs or level of development. And therefore a BIM model can be made to different level of detail. The basic level of detail at initial stages from LOD 100 to 300 is typically used by designers such as architects, engineers. And LOD 300 to 400 is more applicable for the construction agencies themselves. And the LOD 500 then is as-built and highly detailed and also used by facility managers for even managing their facility schedules. Here are just some examples just to familiarize what LOD 100 would be like. That represents basic massing and quantification of spaces. It is used by designers at the preliminary conceptual phase. Then at LOD 200 is also used by designers, and these are spaces are modeled within bounding elements. So elements start getting defined as walls and columns, and the quantification of perimeters and spaces happens at this stage. And LOD 300 typically is used by construction agencies. The wall veneers are modeled as separate elements. The walls are modeled to actual dimensions. And even the penetrations are modeled to nominal thickness. And the quantification of individual materials is possible at this stage. And LOD 350 is typically used by designers and construction agencies, and it would start involving the level of, let us say, GFC drawings. So wall framings are modeled, the support structures would be modeled, all penetrations are modeled. And let us, in this example, we can see the elements that are in red. So those would get defined and then they cannot be cut easily for coordination with MEP elements. Then LOD 400 is typically used by construction agencies. The entire wall framing is modeled to support the fabrication. So at this stage, the fabrication details, outputs, elements, materials, quantification could be obtained easily. Connecting elements are modeled and includes but not limited to fasteners, clips, other hardware. And detailed quantification, of course, will include up to the extent of the fasteners, etc. required. So what are the benefits of BIM? Of course, BIM itself is a highly detailed topic, and it's people would, anybody interested would obviously take it further, which we can discuss or Ashit could discuss. But BIM basically brings together all of the information about every component of a building in one place. It makes it possible for anyone to access that information for any purpose. So that single model could also be shared. And it helps to integrate different aspects of the design more effectively. In this way, the risk of mistakes or discrepancies is reduced and abortive costs are minimized. BIM data can also be used to illustrate the entire building life cycle from cradle to grave, from inception to design, and to demolition, and including materials reuse, spaces, systems, products, and sequences can be shown in relative scale to each other and in turn relative to the entire project. So we can see what high level of efficiency can be there, and here we can begin to see the link with sustainability. And by signaling conflict detection, BIM prevents errors creeping in at the various stages of development or construction. So let's look at BIM and sustainable construction. So sustainable construction in the Lafarge Holcim Foundation article is defined as that sustainable construction involves issues such as the design and management of buildings, materials performance, construction technology and processes, energy and resource efficiency in the building. In his article, David Bursek in constructibletrimble.com states that there are three main connections between BIM and sustainable construction. The first is greater transparency during the design phase. Second is the greater efficiency during design and construction phases. And third is greater control during the operations phase. How BIM offers greater efficiency during the design and construction phases. The BIM 3D virtual prototypes can be easily shared and used for real-time collaboration and simulation to test the logic and sequence of construction. From estimate and takeoff to layout and ongoing project management, every step in the design and construction workflow is reviewed and enhanced to the extent that BIM technology is integrated. These improvements can be seen in speed of job completion, the efficiency and cost saving that come from prefabrication, a reduction in errors and ad hoc troubleshooting, a reduction in crew redundancy, and an improvement in asset management. What about BIM in the COVID era? So here I quote from an article in World Economic Forum by Fan Yulin, saying, here's how smart construction could transform home building after COVID-19. He states, the construction sector is already using building information modeling. During the COVID-19 lockdown, BIM was more widely adopted in the industry. It enabled projects to continue in a digital and virtual environment, even when the participants were unable to meet in person. This collaborative approach allows data to be shared across professional disciplines and businesses and facilitates smarter construction. Especially in the prefab industry, the data can be fed into manufacturing processes for components and modules that are later put together to form finishing buildings. The same article goes on to state that the future of the construction industry is digital, and BIM is the future of design and long-term facility management. It is driven by technology and clear processes, and it is implementing change across all industries. As hardware, software, and cloud applications herald greater capability to handle increasing amounts of raw data and information, use of BIM will become even more pronounced than it is in current projects. And that is really the way forward for us to make concerted and renewed efforts to really incorporate BIM and promote BIM in our various construction industries, in our processes, in our design stages. And I think with that, on that note, I would leave and say thank you. And I also thank Ashit for creating this. So thank you all.